Okay, so let's have a look at some standard model past paper questions. Revised specimen paper. The letters X, Y, and Z represent missing words from the following passage. There are four fundamental forces. Gravity and electromagnetic force act over a what? The strong and weak force act over a Y range, and the Z force is responsible for beta decay. Right, well, first of all, gravity and electromagnetic force act over a long range. If you think about it, you've got gravity, which acts on objects which are in space, similarly with electromagnetic force. So it has to be long, cutting out A, cutting out B. The strong and the weak force, they act over a very short range. They're the ones that are associated with the forces holding particles together, neutrons and protons. So those two are correct. We're cutting out D. The weak force is associated with beta decay. Because remember, the weak force is what holds the protons and the neutrons in that stable nucleus. So our answer is C. The 2014 revised higher. Physicists study subatomic particles using particle accelerators. Pions are subatomic particles made up of two quarks. There are three types of pion: pion plus, pion negative, and pion naught. Pion plus has a charge of +1, pion negative has a charge of -1, and pion naught have zero charge. A pion plus particle is made up of an up quark and an anti-down quark. Is a pion class as a baryon or a meson? Well, pions are made up of two quarks, so that means they must be mesons. The charge on an up quark is +2/3. Determine the charge on an anti-down quark. Well, we're told here the pion plus charge particle is made up of an up quark and an anti-down quark. We're told also that the pion plus has an overall charge of +1. So if the charge on an up quark is +2/3, the anti-down quark must have a charge of +1/3, because 2/3 plus 1/3 equals 1. In this case, +2/3 plus 1/3 is +1. The pion negative particle is the antiparticle of the pion plus particle. State the names of the quark which make up the pion negative particle. Well, the pion negative particle is just the opposite of the pion plus particle. So that must be made up of an anti-up quark plus a down quark. Because an anti-up quark is the opposite of an up quark, and the down quark is the opposite of an anti-down quark. Here's the Sqa Marking Solutions. So we can see where everything is going on here. Now, these are from the revised higher, so we have half marks. We wouldn't have that anymore, so this question probably would be worth 2 marks in CFE. More past paper. Okay, so this is a CFE specimen paper, the first one that was released. Question 7. Protons and neutrons are composed of combinations of up and down quarks. Up quarks have a charge of +2/3, whilst down quarks have a charge of -1/3. Determine the combination of up and down quarks which make this up. Now you should actually know this, but we can figure it out. A proton has a charge of +1, which means that it's made up of +2/3, +2/3, -1/3. So that is up, up, and down. A neutron is overall 0. So that's made up of +2/3, -1/3, -1/3, which is going to up, down, down combination. Name the boson that is the mediating particle for the strong force. Well, the photon is the mediating particle for the electromagnetic force. The W and Z bosons are associated with the weak nuclear force. So the boson, that is the mediating particle for the strong force, is the gluon. A neutron decays into a proton, an electron, and an antineutrino, as shown here. Name this type of decay. That's just knowledge. That is beta decay. And remember, beta decay was the experimental evidence to prove the existence of the neutrino. And here are the marking instructions from the Sqa. Next, we have this diagram, which gives information on the standard model of fundamental particles. Notice included in here is the range and relative strengths of the different forces. We'll be looking at that a little bit later on. Use the information from the diagram and your knowledge of physics to answer the fundamental questions. Explain why particles such as leptons and quarks are known as fundamental particles. Well, fundamental particles cannot be broken down further, unlike protons and neutrons, which can be broken down into quarks. A particle called the sigma plus has a charge of plus 1. It contains two different types of quark. It has two up quarks, having a charge of plus 2/3, and one strange quark. What is the charge on the strange quark? Well, if I've got two up quarks, I've got plus 2/3 plus 2/3, going to 4/3 overall. In order to get to just plus 1, that means that the strange quark must have a charge of negative 1/3, which equals plus 1. Explain why the gluon cannot be the force-mediating particle for the gravitational force. Well, the main reason for that is due to its range. The range of the gluon is very, 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 very small. So we can say that the gluon range is too high. Sorry, too short. You could also argue that the gluon strength is too high. Here's the Sqa. The particles cannot be broken down into further subparticles. We've got plus 2/3 plus 1 negative 1/3. Strong force associated with gluon acts over a very short distance, whereas the gravitational extends over a very large, that's infinite distance. Here from the revised specimen paper, conversation is overheard between two pupils who are discussing their science lessons. Pupil A, we learned in science today that the nucleus of an atom is made of protons, which are positively charged, and neutrons, which have no charge. Pupil B, that's interesting because we learned in science that charges repel. How come the protons in the nucleus don't fly apart? Pupil A, I don't know. Write a paragraph that explains to the pupils why the protons in a nucleus do not fly apart. So this is like an open-ended question here. So we're looking at what holds the protons and neutrons together. So we're looking at gluons. We're looking at the forces holding those two things together. We're looking at saying which statements are correct, which statements are incorrect. Right? So it's pupil A, definitely correct. Neutrons are definitely neutral, and protons are definitely positively charged. It's the interaction of the gluons with the strong nuclear force which stop the positive protons from flying apart. Protons and neutrons each contain two different types of quark, the up quark, which has a charge of plus 2/3, and the down quark, which has an electric charge of a negative 1/3. The overall charge on the proton is, the overall charge on the neutron is 0. This is like the previous question we had. The reason why the overall charge on a proton is plus 2/3 is because it is made up of an up, up, down set of quarks, and the neutron is made up of an up, down, down set of charge. So that is plus 2/3 plus 2/3 negative 1/3 plus 2/3 negative 1/3 negative 1/3. This one equals plus 1 and this one equals 0. So here's the answers. So we have to have reference to the nuclear force, talking about how that holds the protons together. The nuclear force acts to oppose the electric forces on the inside, which would cause the protons to depart. So the weak nuclear force associated with W inside bosons is what give those particles their charge, and that would force those apart. But the strong nuclear force associated with the gluon is bigger and overcomes it. We get to a point then when the strong nuclear force associated with the gluon is equal and opposite to the weak nuclear force, causing a balance point, at which point our nucleus is stable. And part B is as we marked.